Okay, stats, let's continue with the scary variable on scary formula on page 5. The linear correlation coefficient. So mathematicians came up with a way to measure how strong the relationship between two variables is. It's called the linear correlation coefficient. It's R, and it's the sum of all of the, basically, it's kind of like the product of z-scores. Because this is the x value z-score, because it's your score minus the average divided by the standard deviation times the y-score minus the y-average over the standard deviation, and you add them all together and divide by n minus 1. And we'll get to doing that in a table in a second. That number is always between -1 and 1, and if it's 1, you get a strong positive correlation, or close to 1, strong positive. If it's -1 or close to -1, it's strong negative. And if it's 0 or close to 0, there's no strong linear correlation. Page 6 is a bunch of pictures of what that could look like based on your data. Now let's talk about this formula and how you might get things. Remember, if it's a positive correlation, that means as your x's get bigger, your y's get bigger. So if you have a bigger than average x, this will be positive because you should be bigger than average. You should also have a bigger than average y. So positive times positive is positive. How would you get a negative number? If your x's are going up, so they're bigger than average, but your y's are going down and they're smaller than average, positive times negative is going to be negative. So you'll probably be adding a bunch of negative numbers. And if you're thinking, what about the positive correlation on the small side? If this is negative, below average, if it goes down, then your other value should be going down, so negative times negative will still be positive. We'll look and see how this relates. On page 7, they take that same scatter plot we did on problem 3 on the last video, and they do it with just 6 values. Now, in order to calculate this, you'll notice that I need the mean and the sample standard deviation for x and y and the number of samples. So for this table, you can calculate it yourself in your calculator, but I calculated them for you just so we're going to go through and see what these look like. So we've got the x column and the y column, hours and grade. Now we have to do x minus x bar over the standard deviation of x. Now I have x bar and the standard deviation of x listed here. We're going to take the x value 6. So that would be 6 minus 4.17, and then all of that divided by that 2.64. And when you put that in, you get 0.693. I'm going to leave it there at 3 decimal places. Do the same thing for the next data. 2 is our x value. It's still minus the average and divided by the same standard deviation, so at least you only have to change the first number. This one is negative 0.822, rounding to 3 decimal places. Same thing for 3. Next data. If 3 minus 4.17 divided by 2.64, we get negative 0.443. Next with 8. When we plug in 8 to the formula, we get 1.451. Do the same thing for 1. We get negative 1.201 if we round. And lastly, plug in 5. 0.314. Okay. So now we have to do all of the same things for y. Now y's average was 73.83, and y's standard deviation was 14.89, as you can see to the right side. And now, since we have those two, we have to plug in all of the y values. So the y value for the first test score was 82. So we do 82 minus 73.83, and then all of that divided by 14.89, we get 0.549 when rounding, or 0.549. If you want to put the zeros in, you can. Let's plug in the next one. Our next test score on the list is a 58, and that is a negative 1.063. The next test score was a 70. This is negative 0.257. After that, we've got the 98, which is 1.623. We've got the 60 as the next test score, negative 0.929. And lastly, our last test score is the 75. So 75 minus 73.83 over 14.89. This is 0.079. Now, according to our formula up at the top, I'm supposed to take whatever value I get for the x thing and the y's and multiply them together. So in that case, it's our column 3 and column 4. I'm going to multiply column 3 and column 4 together. So for the first one, I have to do 0.693 times 0.549. And I'm going to round this to 3 decimal places as well. This is 0.380. Do the same thing for the next one. It's the negative 0.822 times negative 1.063. We get 0.874. And so on and so forth all the way down. So negative 0.443 times negative 0.257. 0.114. Then we've got the 1.451 times 1.623, which is 2.355. Negative 1.201 times negative 0.929. 1.116. And then lastly, we've got the 0.314 times 0.079, which is 0.025. Now, I need to add, it says I'm supposed to sum them all together, so I need to add all of these together. So add all of the last column together, 0.380 plus 0.874 plus 0.114 plus 2.355 plus 1.116 plus 0.025. So if I add them all together, I get 4.864. Okay, now it says I'm supposed to, R is equal to that sum divided by n minus 1. N is our number of terms. So in this case, our sum we said is 4.864. We've got 6 total entries, minus 1 is 5. So 4.864 divided by 5 is 0.973 if we round to 3 decimal places.